let's take a look at how you would compute inverses using Maple. So suppose we had the following three matrices that we wanted to find the inverses for. The basic place to start would be to enter these matrices in, and I'm going to show you three different ways to compute their inverses. So for the first matrix, let's take a look at entering this guy in directly, 1, minus 1. 1 by columns. The second column is 2, 0, 8, and the third column is 4, 5, 5. So here's the first matrix right here. Now, one of the easiest ways to find an inverse in Maple would be to select this, right-click, and to see if that option appears as a context option. Now we have Browse, Export, Map onto, Conversions, Curve Fitting, Eigenvalues. At the very bottom we have Standard Operations, and when I click on the Standard Operations tab, Inverse is one of the very first ones here. So if I select Inverse, I can find that the inverse to this particular matrix is given right here. Now, as a way of double-checking that this is in fact the inverse matrix, I could multiply this guy times this guy and see if I get the identity. So as a check, let me take that. I'm going to take the matrix there at line 1, multiply, remember that's the dot, with the matrix given in line 2, and see what I get. I get the identity. That is in fact the matrix. So this is one way to do a matrix inverse. For the second matrix, let's take a look at a different way. Let me enter in that second matrix first. By columns, it's 6, 5, 7, and then 0, 1, negative 5, and then minus 8, 2, 1. So here's this matrix. Let me name it temporarily. Let's just call it B for a second. Now if I were to give this matrix the name here, the symbol that we use in math for an inverse is to take the matrix and raise it to the minus 1 power. And interestingly enough, in Maple, if you were to do that to a matrix, it would also return the inverse. You don't even need to name the matrix that. If I were simply to have entered this right here, I could take line 1 and ask for line 1 to be raised to the negative 1 power. And I would still get this matrix at the very, very end. So it's a ghastly looking inverse matrix. And once again, let me check that I do have a matrix by multiplying these two guys together. This time I'll take the inverse matrix, number 2. I'm going to multiply it with the period against the original matrix in line 1, and I come up with the identity matrix once again. So I do have the inverse matrix. For this last example, let me practice entering this matrix in using the other option of the matrix builder. This has 4 rows and 4 columns, so I'm simply going to set the rows to 4, the columns to 4, insert the matrix, copy it in row by row, 1, 2, 3, 0, 5, 7, 8. Oops, that should have been 0, 5, 7, 8. I need to go and write those by hand. 0, 5, 7, and 8. And now 1, negative 3, 1, 0. And finally 2, 4, 11, and 8. There's that final matrix right here. Oops, I forgot a comma. There we go. Here's that final matrix right here. Now, if I try using the right-click technique, I go down to Standard Operations and Inverse, and I get an error. It says that this matrix is singular. If instead I try to raise this thing to the power negative 1, so I'll take the equation on line 1 and raise it to the minus first power, I get another error message, singular matrix. So that's telling me that this guy doesn't have an inverse. So what's this third method for finding an inverse? Well, remember that our method in class was to take this matrix and append it to the identity. So I could actually go and take the 4 by 8 matrix whose elements are 1, 2, 3, 0, and then the first row of the identity matrix 1, 0, 0, 0. The second row would be 0, 5, 7, 8, and then the second row of the identity matrix 0, 1, 0, 0. The third row would be 1, negative 3, 1, 0, and then the third row of the identity matrix. And then finally the last row, 2, 4, 11, 8, 0, 0, 0, 1. So I've taken the original matrix here and I've appended it with the identity matrix, and now I could row reduce this. If I go down to Forms, to Reduced Row Echelon Form, I see that in the Reduced Row Echelon Form I have a pivot, a pivot, a pivot, but a 0 right there. And that tells me one more time that this matrix is singular.